All right, so what I worked on for the last few months at Netflix goes a little something like this. Let's first go like this. Let's bring up some Excalidraw. I'm trying to explain to people how garbage collection works over there. Let's jump in here. Let's hit them with the grid mode. Let's go back into dark mode. Sorry, dark mode screws up the colors. That's why I don't like to use it. Okay, so if you don't know anything about how streaming works, like say on Twitch or anywhere else, what you're going to do is you're going to have a bunch of these little UDP packets, okay? And then not only are you going to have a bunch of little UDP packets, but you're also going to have what is referred to as FEC packets, forward error correction. Now, this may be Reed Solomon. This may be something else. But you get the idea. No, I don't get a free sub. Shut up! Okay, so here we go. So this would be like video right here, right? This would be video. Hey, it's green. I guess we're going with green today. This one right here will be audio. Typically, audio is going to be a singular UDP packet, no forward error correction, all that kind of stuff. There we go. So this happens. This will happen every effectively 1 out of 30 seconds. We'll send a whole bunch of UDP packets. This will happen 1 out of 50 seconds. And yeah, there you go. So that's like the basic of streaming. It's going to use UDP. It's going to use RTMP. It's going to be kind of, your straightforward stuff that you can go look all over there. There's ice, there's stun, there's all the fun stuff. Now, then, of course, there's like back channel communication, right? You got a communication that goes back to your server. This would be like RTCP. What the hell is it called? I can't remember what it's called. I can't remember all these acronyms. But you send little packets back to be like, hey, I got this packet. I got this video packets. I got all these things. So we don't do that. There's RTX. There's requesting, retransmission, RTX. So like, say this one you didn't get, or you missed 2, so therefore you technically need 1 more packet. And if you get 1 more packet, you are then able to use a FEC encoding to thus get the last packet inside there. FEC encoding is really simple. Just plain old ULP, FEC, uneven level protection, forward error correcting, is really, really simple. It's just literally the XOR of all the packets together into this one. And so if you miss 1, you can just be like, okay, well, just XOR some things together, and boom, you got that guy back out. It's pretty neat. It's pretty neat stuff, right? You get the idea of XOR. If you haven't played with XOR, it's pretty cool. And so that would literally be getting out that thing. There's different versions of it. Like I said, Reed Solomon, blah, 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 blah. Anyway, so we have all this data. We're sending it all over the place. And so one thing I built was a program that we called Reggie, which, by the way, Reggie was awesome. Reggie was one of my favorite projects I've ever done. I really, really enjoyed making Reggie, what Reggie did is Reggie. It's named after a very nice character. You may have heard of him. A very upstanding citizen, Reggie Miller. We nicknamed it the most reliable pacer. And so all it did was it followed this thing right here, and I would actually just create all this data based on a 30-second clip and feed it in as fast as I possibly can. And then you know what I'd do? This is the good part. Is that I would actually bypass all of like the playing and everything, and I'd have a sync component I written on the other side in C that would receive all this information and have a huge like calculation and tell us like how much loss we're having, how much we're dropping and all that, except for I'd play it faster than time, faster as possible, right? So I'd be shoving in these packets as fast as possible. And how Reggie effectively worked, which I thought was pretty clever, is that if you don't know anything about a TV, this is effectively what would happen, or at least Netflix TV, right? Is that you have like the JavaScript layer, right? So we have this nice little JavaScript layer. Then we have this we have the C++ layer, right? And then we have what would be like the partner layer, right? And so the partner layer is, like this is where the TV actually does the TV things, right? So this guy right here is like us taking in all the video and making a video and then going and handing it off to the partner. Then the partner actually puts it on the TV, right? And so we have like some basic what we call like interfaces that we kind of communicate through, and that's just what happens. And so Reggie was written in JavaScript to create all this stuff. And then what I did is I created a fake partner. I created me. I was my own partner, right? And so I had another one, the Reggie Sync. And the Reggie Sync Uwu. And what it would do is it would receive all these packets and keep a bunch of math statistics around. Effectively, it's just a big, giant running dynamic programming where the JavaScript would emit 1 frame, right? So I would emit 1 frame oopsies, 1 frame worth of data of both audio and video. And we could put I could make it so that it comes in varying amounts, how much effect was going to be happening. All sorts of fun stuff would happen. It would get this 1 frame. The 1 frame would then be passed over to Reggie. Reggie would take this 1 frame and be like, okay, I'm at ID 1. I have, it came at the timestamp of X. That means, and I have this much video buffer, right? I have this much video buffer, right? Y. I have this much audio buffer, right? So I'd have all these stats kind of there. And then what I would do is that I would then query from JavaScript and be like, hey, does Reggie, do you have here? How do I do a little break? I don't know how to do this little break thing. There we go. I would query here and say, hey, what ID are you? What ID are you? And the moment it got 1, which is the one I just sent, I send another frame. And I also update the time of the system. I send another message where I update the time of the system, and I just say, hey, let's pretend that we're currently at time, we're at time plus X plus 16.66, or whatever our thing is, right? Whatever the speed is. And so I'd update the time virtually, then I'd send a new frame. Update the time virtually, send a new frame, and we'd accumulate all the stats here. And I just run as fast as I possibly can through this, which means I was running as much data as possible, as fast as we could to test out our C++ layer. And not only that, but I could create situations, right? Let's say the internet dipped out for a second. What would happen? What would this layer do right here? Would this layer do all the correct things? We'd do all the required stuff. And it was very, very fun. And so this was kind of like my project right there. This was Reggie, the most reliable pacer. Very, very fun. A lot of science went into this one. And so this one, what I could do is I could take the client and just ramrod it as fast as I can, see how much memory is produced and how much stuff is used. And are we overflowing audio? Is audio being handed off properly, or are we not doing the right thing? If audio dips below and we accidentally go to 0, what does the C++ layer do? Does the C++ layer properly queue up enough audio to send it again? Because ALSA, if you don't know about ALSA or a lot of these things, they require 20 millisecond chunks. You can't just send 10 milliseconds in. You have to do 20 milliseconds, and each one of these packets are 20 milliseconds. By the way, writing your own Opus encoding for silence, or just like a beep, 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 it's really annoying. You know what I mean? It's not a fun task to do. You have to go figure it out and get stuff sent in and make audio actually be audio and all that fun stuff. Because Reggie would also work in real time as well, meaning that I could just send audio and video as fast as I can into a FFmpeg player that's really, really fast. A lot of fun. It's very, very fantastic. Someone's asking why not send real time, why not do real time, blah, 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 and all this kind of stuff. The reason why it would suck to do anything that's not real time is that you can't test stuff fast enough, right? I want to be able to test every situation, and I want to be able to run CI in under 20 seconds, right? I want to be able to play an hour of video. I want to be able to do that one time where I drop audio. I want to do that one time where I drop video. I want to do that one time where I drop audio a bunch of times. I want to be able to do a whole bunch of different things really, 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 really fast, and it has to work with our system. I don't care about DDS because it doesn't work with our system. You know, I have to make it go through TV and all this fun stuff. You know what I mean? So I have to hack time and make it work within our bounds. I can't just, why would I use something else? You know what I mean? I have to have direct ties into the C++ layer. It has to run directly in JavaScript, right? And so it was a lot of fun. Any backstory and lore? Yeah, the most reliable pacer. That is it. I was watching a documentary that featured Reggie Miller, and Reggie Miller was just a really cool guy. He was like a really nice guy. I liked him. I thought he was pretty cool. And so watching Reggie Miller, and all of a sudden I have to build something that paces packets in, it was just natural to have Reggie Miller, Reggie, right? It was a lot of fun. So that's the first thing we built. The next thing I did was a whole bunch of stuff that involved all of this data that's happening. How do we know, how do we know forward error correction is working in the field? Not theoretically in a made-up situation, but how do we validate that it's working in real time, in real life, on people's computers, right? Are we actually error correcting? Are we actually doing anything correct? Or are we just like completely driving blind? And so my next goal was to effectively drive a lot of this area of just like, okay, how do we know what we're doing right and how do we know what we're doing wrong? Forward error correction. You can just look it up. It's pretty easy. ULP forward error correcting, right? There's a whole bunch on this kind of stuff, right? Very, very simple. There's also Reed Solomon. There's all these other ones, you know. And then, by the way, if someone doesn't like the name Reggie and they don't like basketball, I just tell them that it's named after Reginald Hargreaves of the worst show ever, The Umbrella Academy. It's just a blueprint, or does it have some implementation? Oh, it has implementation, and it was mostly a blueprint. I didn't implement any of the stat stuff. I just simply used the stat stuff, built tools around it, and kind of drove people to do the right stuff. Like I defined a lot of the status events that are going to be coming off the OCGAs. That's the Open Connected Gaming Machines, right? So our gaming machines, you know, since we're doing RTP, they receive basic statistical things about like what's happening, how good is our network, how often is it dropping, how often are we doing this, how often are we doing that, all the kind of just basic stuff. I took all of that and was just like, okay, here's the stats that I really think are useful. Here's the stats I really think are useful. I like the idea of the Umbrella Academy. It was a show that could have been made in half the amount of episodes. How do you learn all these things? You just do it. Umbrella Academy could have been made in half the episodes. That's pretty much it. And I think I can't even remember, but Five, the little kid, he was the only likable character. The rest I just found so unlikable. I love your content. Rekindled my love for hobby programming. Nice. Okay, cool. How do you prioritize packets on network failure/hiccups? So that's what we're going to be doing things with like FEC. FEC should hopefully do it. You also have RTX. RTX does that. But if none of this works, if you're delivering video, at some point, if things aren't working, you just redeliver what is referred to as an IDR frame. And an IDR frame contains the full video. And so then you start doing the relative frames from there, right? So you just need one big frame if things start falling apart. You know what I mean? Will it be open source? Absolutely not. Absolutely not. So anyways, that's that. And so the stats part, which I've been working on, because a big problem we were having next is that every single time we would do anything as we're just starting to test, how do we know a game failed? How do we know anything went wrong? So I just took all of our data sources and built a rapid triager that would tell us what's failing and where is it failing and who's to blame. Is it the client? Is it the server? Is it the network? Like, what caused the problem? And what was the problem? Because people often would just be like, my game was really bad. Audio was really bad. Video seemed a little chunky. This, right? They'd give us some verbal description, and we'd have to go figure out what the hell happened. So I just take all the data, every last thing, and then just be like, oh, your audio is bad. Yeah, look at your network. Like, look at these network times right here. You totally just chunked out. Are you on the VPN? Oh, you're on the VPN. You're on the VPN, and you're at your house, and you have bad internet. Yeah, that's this. I mean, this makes sense. This is why what happened, right? Like, you know, do that. Yeah, so it was a lot of fun. Like, those kind of things were a lot of fun. And so it's all OCGA work. It's all like what our servers receive and send. It was kind of fun, you know. And then we had a whole bunch of problems like JSON. We were using, the first version was using JSON to pass events. We literally just caved the game server encoding and decoding, or just encoding JSON. That's it. Just encoding JSON completely caved the game server. So then it went into protobufs, and then we got some Go zero allocation, or like zero garbage generating protobufs. Very, very cool. That really helped the whole servers run nice. You know, it was fun. It was a lot of fun. I enjoyed it. I worked on all my stuff alone, yeah. But, you know, I worked with a lot of people to get things going, to get things out there running. Not memory arenas, no. There's some cool Go stuff that does these, like, zero allocation protobuf stuff. It was fun. It was a good time. I really enjoyed it, and so we were just doing that. And I still got a little bit, I got one last thing I got to do, which is I just got to do one more of these little data things, and then I'm pretty much off the project, and I'm on to my next project, which involves React. But it does involve subverting React. So that's pretty fun. I mean, that part's pretty cool. So I'm happy about that one. You know what I mean? You know what I mean? It does involve making React become not React, right? And so it was pretty exciting. I'm pretty excited about that part, actually. I actually really like the thing. And guess what? I get to build an LSP for it. So I'm going to be building an LSP. You have to write a lot of Rust. I got to write a lot of JavaScript. Yeah, it's been fun. It's been fun. Anyways, the name. Hey, did you know I work at Netflix again?